So this is the first equation that we have. And the second equation is based on the moment. Okay, so total moment equal to 0. Maybe moment, let's say this point equal to A, and here this point equal to B. So let's say you choose point A as your reference. Okay, total moment about A equal to 0. Okay, so and then you define the positive moment to this direction. Okay, for example, so we have 800 kilogram. Okay, and the distance equal to 2. Okay, minus PBZ, PBZ. Okay, PBZ and the distance equal to 6, equal to 6, equal to 0. Okay, so from this, okay, you can determine what is the PBZ. Okay, PBZ, so you can determine the PBZ. So after that, you can put it here. Okay, PBZ here, and then you can determine the PS, P steel, P steel. So this is the first two steps. First is to draw the free body diagram. So this is a free body diagram. And then the second step is a force analysis. You can apply the equilibrium equation. In this case, we have all these two unknowns. So we just apply the total moment equal to 0, and the total force in y direction equal to 0. So you can get the PS. PS means that the force in steel cable, and PBZ is the force in bronze. So after that, you just put it here. You just put it here. Okay, this is PS. Okay, this is PBZ. So from that, you can determine the diameter, because this is PBZ. Okay, and the diameter for the bronze equal to pi over 4d square. So this is for the bronze, the bronze. Okay, and for this one from here, okay, you know the PS and the area of steel. Okay, so P steel divided by the pi over 4d steel square. So you can determine the steel. Okay, d steel and the bronze from this equation. Okay, are you clear? You know how to solve this problem? Okay.
Clear, Doctor.
Yeah. You understand, huh? You can follow me?
Yes, Doctor.
Okay. Okay. So this one is quite straightforward, huh? But you have to understand how to solve. Okay. Okay. So if you have no problem, we proceed to the next example. So this example, actually, this example 6 and 5 and 6 is quite similar. Quite similar. Okay, in this case, we have the rigid bar OAB, supported by the link AC. So supported by the links mean that this is two force member. This is two force member. Link AC is made of aluminum and has cross-sectional area of 500 millimeters squared. For the 10 kilonewton force shown, we have a force at point O, okay, 10 kilonewton. So first, determine direction at pin C. What is direction force at pin C? Sigma in the link AC. So this is sigma AC. So this one equal to FAC, okay, divided by the area of AC. AC. Okay. So this is the average normal stress. So we go one by one. The first one is reaction force at pin C. So what you have to do is draw free body diagram. Let's say we have this is the By. This is as a Px because this is a pin connection. This is a pin joint. So we have two forces here, Bx and By. Okay, component in x direction and y direction, and at point A, Okay, because of the two force member, okay, links force member. Let's say we assume that this is as AY, or maybe you can put it here AY to the downward instead of upward. It's up to you. Okay, so from here we can see that the component of of x in x directions is only bx, only bx. So there is no more force in x direction. So automatically, so bx equal to 0. Okay, because when you apply the total force in x direction, so bx equal to 0 because there is no more force in x direction except bx. So automatically bx equal to 0. So if bf equal to 0, so from this free body diagram, we have two unknown. So ay and also by. Okay, so from total Fy equal to 0, okay, total Fy equal to 0. Okay, so we have Ay plus By minus 10 equal to 0 or equal to 10. Okay, this is the first equation we have. And the second equation is based on the moment. So I think for the moment, we take B as a reference. Okay, moment about B equal to 0. Okay, moment about B equal to 0, and you can define the positive moment. Okay, positive moment to this direction. Okay, let's say this direction. So we have 10 kilonewton. Okay, negative. Okay, the distance is OA is 0.6. AB equal to 0.4, 0.4. Okay, 0.4. So 10, 1 meter. And then plus AY, plus AY, and the distance from B, distance from B equals to 0.4, 0.4. Okay, 0.4 equal to 0. So from here, you can determine the AY. AY is positive or negative? Positive. Positive is equal to 10 divided by 0.4. So this one equal to 25. Is it correct? How much?
Yes, yes,
Yes,
25.
sir.
25.
So 25.
25 kilonewton. 25
Kilonewton,
kilonewton.
yes.
Yes.
Okay. AY equal to 25 kilonewton. Okay, so uh, so at a pin C, yeah, at pin C. So what is reaction force at the pin C? Okay, what is reaction force at the pin C? If you draw, okay, so this AY is to this direction based on the bar OAB. Yeah? So when you draw the link is C, C link AC. So this is point C, this is point A, this is point A, this is point C. So the direction of AY is to this direction. Okay, this is the AY. Why AY downwards, not upward? Why? Why in this case, AY, the direction of AY is downwards, not upwards like this. Why?
Because once it's combined, it will be cancelled.
Pardon? Why? Because
Because when we combine pin at A, we will cancel
cancel.
the A1.
So based on what? Based on Newton
That law.
third law. Okay, this is based
Action,
on
reaction.
action and reaction force. Action and reaction force. Okay, so if in the body OAB, AY is upward, so for the link AC must be downwards at point A. Okay, and then if AY to this direction, so at point C here is must be upward. So this is CY, and then CY is must be the same. Okay, if you apply the formula total FY equal to 0, so CY equal to AY. Okay, this is equal to AY. So AY equal to 35 kilonewton. So this is the answer for question for the part 1. So AY equal to CY equal to CY equal to AY equal to 25 kilonewton. Okay, 25 kilonewton. Okay, and then based on that, what is the average of normal stress? The average normal stress equal to sigma FAC. FAC here represented by the AY. Okay, AY. Okay, AY or CY. Okay, because AY equal to CY. Okay, FAC in this case, force in body AC equal to FAC, and FAC here represented by the AY. Okay, 25 kilonewton. And the area, okay, area is given here is 500. Okay, 500 millimeter square. So you can convert to meter square. So this is 25. This is 25 kilonewton. Okay, divide by the area. Area is 500. Okay, multiply by 10 minus 6. 10 minus 6. 10 minus 6 because we convert to meter square. From millimeter square, okay, millimeter square to meter square. So you have to multiply, okay, 10 minus 6. Okay, 10 minus 6. Okay, so that's how we solve this problem. Okay, step by step. Okay, so we start with the free body diagram. Okay, you can see that. You can see that from the free body diagram, and then from free body diagram, you go to step 2. Step 2 is the force analysis. You apply total Fy, and then you apply the moment and so on. So based on that, you can determine the unknown. So unknown here is By and Ey. Okay, and then after that, you proceed to the you can refer to the question. What question asks you? So in this case, the question asks you what is the reaction force at pin C. If you know the reaction force at pin A, so automatically you know the force at point C, because this is two force member. Okay, so that's why AY equal to CY, because this is two force member. And then, okay, what is the average normal stress? Okay, for the link AC. Okay, so for the link AC is force here equal to FAC, and FAC here equal to AY. Okay, so any question you want to ask me? Any question? Any question if you want to ask me? Okay, I hope you take the note. You can take the note. Okay, maybe before this you can refer again and again until you understand. Okay, so maybe because I have a very limited space here, so maybe the sequence is not proper. So I hope you can take the note. Okay, any question? Any question, please?
No question, Doctor.
No question, huh? So I think this very easy, yeah. Okay, so this example, another example. Okay, you can try to study this one, huh? So I think this example is actually quite similar for this one. Okay, for this one, huh? Okay, quite similar. Okay, the concept is the same. Okay, so the bar has a constant width of 35 millimeter, and the thickness is 10 millimeter. This is referred to cross-sectional area. So this cross-sectional area. So this one is cross-sectional area. This is 35 millimeter, and this one is 10 millimeter. Okay, this is cross-sectional area. So this is rectangular. Okay, this rectangular. Okay, determine the maximum average normal stress. We want to determine maximum average normal stress. What is the maximum average normal stress? Sigma maximum. Okay, so sigma maximum equal to P or N divided by A, P divided by A. Okay, in the bar when it's subject to the loading shown. So, because of the cross-sectional area for each section from A to B, from B to C, and C to D is constant or uniform. Okay, like this, uniform like this, constant. Okay, for the section A, B, B, C, and C, D. So, in order to determine the maximum average normal stress, okay, because A is constant, it's the same, so you have to determine which section, okay, which section the normal force is the maximum. Okay, so in this case, you have checked one by one. Okay, you can cut here, and from here you can determine the P force between between point A and point B, and here you can determine the P force between B and C, and you can cut here. So this is force, the normal force between C and D. C and D. Okay. So you can cut. You can cut for each point here. Okay, you can start from A to D or from D to A. It doesn't matter. It's the same. Okay, let's say I start here from here. Okay, this one. Okay, this is point A. Okay, here is 12 kilonewton. Okay, so this is PAB. PAB. Okay, so this is very clear here. So from total Fx equal to 0, so PAB equal to 12 kilonewton. Okay, 12 kilonewton. Total Fx equal to 0. Okay, so PAB equal to 12. Okay, equal to 12. And then for PBC, okay, this one, same thing. Okay, we have this one. Okay, this is 12. And then we have 9, distraction. This is 9, this is 9. Okay, let's say this is PBC. PBC. Again, total Fx equal to 0. Okay, so PBC minus 18, minus 18 minus 12 equal to 0. So PBC equal to 30 kilonewton. So this 30 kilonewton. Okay, 30 kilonewton. Okay. Okay. You understand this one? You can follow me. Okay, how to determine the internal force? Internal force is the force within that body. Is this one is we call external. This is external. This one also external. This one also external. This one also external. This is external force. So internal force. How to determine internal force? You have to cut that body. Okay, you have to cut the body. So when you cut, you can determine what is the internal force. Okay, so this is for the section AB. Okay, this is for the section BC, and for the section CD, for example. Okay, you can cut here. Okay, you can cut here. Okay, when you cut here, you have two parts, left and right. So up to you. Okay, so if you choose the right hand side automatically, so you can determine that PCD equal to 22 kilonewton. Okay, very clear. Okay, if you want to take the left hand side, okay, you can draw one by one. Okay, you can draw one by one like this. So this is 12. Okay, this is 9. This is 9. Okay, and then we have 4 here. This is 4 kilonewton to this direction. This is 4. This is 4 kilonewton. And then let's say this is PCD. PCD. Okay, PCD. Yeah. So total Fx equal to 0. Okay, we have minus 12, minus 18, plus 8, plus 8, plus 8. Okay, minus, plus, plus PCD equal to 0. So PCD equal to how much? PCD? 30, minus 30 plus 8 minus 22. So PCD equal to 22 kilonewton. Is it correct? Is it correct?
Yes, doctor.
Okay. PCD equal to 22 kilonewton. So this is if you choose the right hand side, the left hand side, the section left hand side. If you choose right hand side, so automatically you know. So this is 22. Okay. Okay. So this is PCD. Okay. So PCD equal to 22 kilonewton. So answer is the same. So don't worry. Don't worry. The answer is the same. Okay, whether you choose the right hand side or left hand side, it doesn't matter. Okay, the answer is the same. Okay, the answer is the same. Okay, so that is first step and second step. Then free body diagram and the force analysis. So now we go to how to solve this problem. You want to determine the maximum average normal stress, and then because of the cross section is the of the bar is constant, then 35. Okay, this is the area. This is the area. Okay, that is very constant. So to determine the maximum, we have to determine where is the highest internal force. Okay, based on this, we have the PAB equal to 12, PBC equal to 30, and PCD equal to 22 kilonewton. So from this data that we have, so very clear, PBC, for the body, PBC, the internal force is the highest. Okay, the highest is 30 kilonewton. So from that, the average normal stress is sigma equal to force maximum equal to 30 kilonewton. Okay, 30 kilonewton. Okay, divide by the area. Area equal to 10, 35. Okay, multiplied by 10 minus 6. 10 minus 6. So that is the answer. Okay, that is the answer. That is the sigma maximum, the average normal stress maximum. Okay, maximum. Okay, maximum. Okay. Are you all right? I understand. Okay, so you can refer to this solution. We have the solution here. Okay. Okay. That is the answer. Okay. That is the answer. Is maximum is 30 kilonewton, and this is the area. Okay, area is 35 multiplied by 10. Okay, so the maximum average normal stress equal to 85.7 megapascal. That is the answer. Okay. Any question you want to ask me? Okay, please let me know. I don't know whether you understand or not. So if you feel that you cannot understand, or maybe you feel confused and so on, okay, please let me know. Please let me know. I try my best to help you to make sure you understand. Okay, from the beginning. If you cannot stand from this beginning, it's very hard for you to understand the after this. You can. It's quite hard for you to understand. Okay, please, please let make sure you understand. If you have any problem, please let me know. Please let me know. Okay. Any more question? No question?
No, sir.
No. No question, huh? Okay, so if no question, we go to the second part. We just finished discuss about the average normal stress. So we go to second part is what we call as average shear stress. Average shear stress. Okay, so average shear stress equal to tau. Tau equal to V over A. V is the shear force, A is the cross-sectional area. So for the average shear stress, we have two different shear. Okay, we have two different shear. Okay, what we call as a single shear and double shear. Okay, single shear and double shear. What is the single shear? What is the double shear? Okay, so let's say this is the plate, the plate. Okay, and there's a cross section like this. This is the plate, and you put in the platform like this. Okay, maybe this is the floor or platform, and then you apply the force here. You apply the force P or F. You apply the force P. Okay, and then when force is increased, the failure start to occur. Okay, to that line. Okay, to this line. So this process we call as the shear. Why? Because this failure due to the shear stress. Okay, when you increase the force, okay, the shear stress will increase or will develop and increase. So until certain point or certain stage, okay, when the average shear stress, when the allowable shear stress less than the average shear stress, so the failure will occur. Okay, okay. So this is the line of the failure. Okay, like this. This, and this V is the shear force. Okay, and this F is the external force. And from here we can measure what is the average shear stress. So this is the average shear stress. So we have two different types of the shear, single shear and double shear. So what is the single shear? Okay, so this is the single shear. Okay, just to make it simple, okay, we have a two plate. Okay, plate number 1 and a plate number 2. So between these two plates, we join with what we call, what is this? What is this? What is this? What is this?
It's a rivet.
Rivet.
Pardon? Rivet.
Rivet.
Rivet. This is not rivet. Bolt
Nut.
and nut.
Bolt and nut.
Bolt and nut. Okay, so this is, okay, when we have a two plate, okay, and then when we want to join, okay, so we can choose various type of joinings method. Okay, this method is we join between the two plates we call as bolt and nut. Okay, we have bolt and nut. I think you are familiar. Okay, so it's a bolt. Okay, this is a bowl. Okay, you can see here, this is the bowl. This is the bowl. And then we have the nut here. We have nut. Okay, we call it as bowl and nut, like this. Or sometimes we can use what we call as rivet. Yes, correct. Okay, rivet. Or maybe we can use a pin. Okay, so this is what we call as mechanical fastener. Okay, mechanical fastener. Okay, because this joint is based on the mechanical. Okay, sometimes we can join between these two plates. Maybe we can weld. Okay, we can weld here, or maybe we can use adhesive or the glue. Okay, it's okay. And so this is how we can join between these two plates. Either you can use bolt and nut, rivet, pin, or welding, weld, or maybe glue or adhesive. It doesn't matter. Okay, so this is the cross section. Okay, so this is the rivet. So this is the rivet. So this is the rivet. Okay, this is the rivet. Okay, so it is a force to distraction and to distraction. So what happened is the failure occur, okay, in this line. Okay, so like this, so like this, when you apply the force here, and this is the failure here due to this shear. So this is we call as a single shear because a shear only occur at one point. Okay, at one point or at one line. Okay, so tau in this case, the formula of the tau equal to V over A. V over A. V is the shear force, A is the cross-sectional area. Okay, the shear force here sometimes we can represent as a P, okay, force or F, it doesn't matter. But you know that for the shear stress, this P refer to the shear force. Whether formula you use V or P or F is it doesn't matter. And the A here equal to pi d squared divided by 4. So this is the area. Okay, so based on this, we can determine the average shear stress. So this is for the single shear. Okay, so the same thing if you join, for example, this is a wood or paper. Okay, sometimes we not join metal by using the glue. Okay, normally we use glue to join paper or to. Okay, so this is the area covered by the glue, covered by the glue. So how to determine the shear stress in the glue? So the same thing, every shear stress in glue equal to V over A. So this is V equal to P, or and then the area covered by the glue equal to LW. Okay, this is L, and then this is W. So this is we call as average shear stress in glue. Okay, so this is still a single shear. So this is still single shear. Okay. So what about the double shear? Okay, double shear is looks like this. We have two plates at the right, at the left hand side, and one plate to the right hand side, and then we apply the force like that. Or this is for the cross section. You can see that this is cross section. So this is half P, this half P. So this one plus this one equal to P. Okay. So if we increase the force P here, we pull, then the failures will occur to this line. Okay, so that's why, because this one is the failure occur at the two location. Okay, so we call it as a double shear. Okay, so this double shear looks like this. So this is a shear line here, this point and this point. Okay, so the formula equal to same. Okay, tau equal to V over A, but in this case, V in this case equal to half P. V in this case equal to half P. Okay, the area is the same, pi d squared divided by 4. Okay, so V equal to half P in this case. Okay, because this is the double shear. Okay, in this question, in the problems, okay, you can, whether the system is single shear or double shear is based on diagram, or maybe in the problem they mentioned clearly stated, this is double shear or this is the single shear. Okay, and the same thing for the glue. Okay, like this is a glue. Okay, the formula is the same. Okay, V divided by the area. Okay, and then V in this case equal to half P. Yeah, so half P. So half P is come from here. Okay, come from here. Okay, from the equilibrium free body diagram. Okay, that is the formula. That is the formula how to determine the average shear stress.
Yeah.
Okay, so the average shear stress,
Kelas lah.
tau equal to V
Ya,
over
kelas.
A. So this is the formula. Okay, now we go to the example. Okay, we go to the example. Okay, for example, okay, so as before, the example is not straightforward. It's not straightforward. You have to understand what happened. Okay, you can imagine, you can visualize. Okay, the system, what happened to the system when you apply the load. Okay, in this case, we have the supporting wheel. So this is the wheel. Okay, this is wheel. On the scaffold, this is a scaffold. Okay, it's held in place on the leg using a 4mm diameter pin as shown. So this is the pin. So this is the pin. The diameter of the pin equal to 4mm. Okay. If the wheel is subjected to the normal force 3 kilonewton here, okay, determine the average shear stress. Average shear stress is tau. Okay, developed in pin A. So we want to determine what is the shear stress in this pin. So from this diagram, the pin is single shear or double shear. Okay, anyone to answer my question? Is it the system is single or double shear? Single or double? Hello?
Double.
Double.
Double, huh? Okay, double. This is, yes, the answer is correct, is double shear. Because, okay, this is the first point or the first part, failure will occur, and here also the second one. Okay, so this is the, we call as a double shear. So neglect the friction between the inner scaffold. So this we call as inner scaffold. This is inner scaffold, puller leg, and the tube. So this is the tube. This is the tube. Okay, it means that there is no friction here. There is no friction here. Okay, we assume that smooth. There is no friction here between the inner scaffold and the tube. Okay, so what is the average shear stress? Okay, so what is the average shear stress? Okay, so in this case, you have to draw free body diagram. Okay, draw free body diagram to represent this problem. Okay, you can draw this one. This is the wheel. Okay, and this is the inner scaffold. This inner scaffold. Okay, and then this is the pin. This is the pin. Okay, so this is 3 kilonewton. Here, kilonewton. This is 3 kilonewton. Okay, and then if here is upward, here must be downward. 3 kilonewton. So at the pin is to this one. Okay, 3 kilonewton. And because it is shear, so we have this is the V. This is the V. This is the V. Okay, so the V here equal to total Fy equal to 0. So we have 2V equal to 3 kilonewton. So V equal to 1.5 kilonewton. 1.5 kilonewton. So this is the shear force at this point. So the tau equal to V, V equal to 1.5 kilonewton. Okay, kilonewton divided by the area. Area is 4 millimeter diameter. Is pi over 4D is 4 millimeter squared. So 10 minus 6. So this is the answer, megapascal. Okay, megapascal. That is the average shear stress for that thing. Okay, okay. The answer is sometimes is quite simple. The answer is quite simple, and the problem is how to get the answer. Okay, once you understand, so I think within 1 minute or 2 minutes you can solve, but it's not so but not too easy. But not so easy. You have to think. You have to visualize. You have to understand the problem is. If you cannot understand, so that is the problem. Okay. Anything you want to ask me about this one, this example, before we go to next one? Anything? Any question? It looks very it looks very simple. Because you have to think about this. Okay. Oh, we have an answer. Okay, I say the answer is the same. Huh? The answer is the same. Yes, the answer is the same. Okay, so the average shear stress equal to 119 megapascal. Okay, 119 megapascal. Okay, so that is the average shear stress for double shear. Okay, we go to this one. Okay, it looks quite difficult, complex, but don't worry about this. Don't worry about the diagram. So what you have to do is to draw free body diagram, and then you can solve it. So in this example 10, the crimping tools. This is we call as crimping tools. Okay, to crimp the end of the wire at E. So this is wire very small. Okay, the wire is very small. Okay. Okay, if the force of 100 Newton, this 100 Newton, is applied to the handle, determine the average shear stress at pin A. So this is the pin A. So this is pin A. The pin A is subject to double shear. So this case is mentioned here. Okay, the pin is subject to double shear. So this pin A is the double shear and has a diameter of 4 millimeter. Only the vertical force is exerted on the wire. Okay. So in this case, what you have to do is to determine what is the reaction force at pin A. Okay. What is the reaction force at pin A? Okay, we have two parts, the top part and the bottom part. So which one you want to choose? Okay, which one? Is it the bottom or the top part? Okay,
Bottom.
which one? Bottom. Why bottom? Why you not choose the top part?
The top.
Top.
Why top? Why you not choose the bottom part?
Because top will have
Less.
3 unknowns.
Less unknown.
Less unknown.
Water.
Okay. So in this case, you have to strategize your answer. Okay, you have to strategize your answer. It means that you have to analyze. Okay, let's say if I choose the top part, okay, top part. So CD is two force member. So we have only one force here. Let's say I assume that this is a CY. Okay, CY. And at point A, we have 2, because this is a pin. So this is, let's say, I just put it as AY here to this direction and AX to this direction, AX. And at point E, let's say to this same as to this. Okay, from this one, you can see that how many unknown we have? How many?
3.
We have 4. CY,
4.
AX, AY, and EY. We have 4. Okay, so how many equilibrium equation we have? We have 3. Okay, maybe. But in this case, you can see that here. So actually AX equal to 0. Okay, AX equal to 0 or not?
Yes.
This AX,
Yes.
Yes.
AX equal to 0. AX equal to 0. So how many unknown?
3.
3.
3. You have a 3 unknown. It means that you can solve this problem. Okay, you can solve this problem. Okay, you can solve the problem. Okay, is it correct? You can solve. Okay, AX, when AX equal to 0, so we have 3: AY, EY, and CY. So how many unknown? Here is 3. So how many equation you have?
3. 3 equation.
How many?
3 equation.
This is 3 unknown. it means that you have to at least 3 equations. So based on the equilibrium, here how many equations you have? 3 or 2?
2.
You have only 2. You have only 2. You have total Fy equal to 0, and then total moment equal to 0. Only 2, 1 and 2. And the unknown is 3. You can solve? You can solve?
No.
You cannot
No.
solve. You cannot solve. You cannot solve this problem if you choose the top part. Okay, so we go to the other alternative, this bottom part. So this one, bottom part. This point D, this point D, okay, to force member. Let's say this is dy to this direction, for example, and this pin at B, we have let's say this is by, and here is bx, bx. Okay, to this part. So from this diagram, how many unknown we have? 3, dy, by, and bx. But from this diagram, you know that bx equal to 0. Okay, you agree with me? Bx equal to 0.
Yes.
You know why
Yes.
bx equal to 0? Okay, bx equal to 0. Because when you apply this equation, total fx equal to 0, okay, only bx in extraction. There is no more force in extraction except bx. So it means that bx equal to 0. Okay, bx is when bx equal to 0, we have dy and by. We have only 2 equations, and then you can apply the total Fy equal to 0 and the total moment equal to 0. Okay, total moment equal to 0. So moment maybe you can choose B or D, it doesn't matter. Okay, but if you want to make it shorter, okay, if you want to make it shorter, your question, your answer, okay, you choose moment at point B or D, B or D. If you want to make it shorter,
B.
B.
it doesn't matter. Actually, you can choose B or D. It doesn't matter. But if you, I think you want to save your time, okay, choose which point, B or D.
B.
B or D.
B.
B. B or D. Okay, you can better you choose at point D. Okay, by. When you know the by, you transfer to this section. Okay, you transfer to this section. You transfer to this section. Let's say, okay, I just draw. Okay, like this. Okay, this is point A here. This is point B. A, B, this is point EY. This is point E, EY. Okay, AX, for example, this is AY, and B. So let's say this is BY, upward. Okay, from the calculation, okay, BY is positive, for example. If negative is opposite direction. Let's say it's positive. We mean that the BY is upward. So when you want to transfer to the second component here, so by must be to, okay, upward, downwards. So by here is upward. Here must be upward or downwards?
Downward.
Downwards. Downwards. So this is by. Okay, by. So this one you know the magnitude of by. And then from this diagram, we have AX, AY, and EY. So again, in this case, AX equal to 0. This one equal to 0. So we have only AY and EY. Okay, AY and BY. Okay, you just take a moment about b equal to 0. So automatically you know what is the ay. Okay, that is the ay. Okay, and then after that, you determine the resultant of the reaction force at point at pin A. So at pin A equal to ax squared plus ay squared, square root. So ax equal to 0, this one equal to 0, so A equal to ay. Okay, resultant force at A equal to ay. Okay, and then after that, that is the reaction force at pin A. So how to determine the average shear stress is tau equal to V over A. And then because of this is the double shear, it's mentioned here, double shear. So V in this case equal to force. Okay, this one force. Okay, force, that one. A divided by 2. Why? Because it's double shear divided by the area. Area equal to 4 millimeter is pi over 4, 4 squared 10 minus 6. 10 minus 6. Okay, so from here you can determine the double shear. So this A, okay, A is come from here. A come from here. Okay, that's all. Okay, that's all. Okay, don't panic, don't panic when you see the diagram. The diagrams looks very difficult, sir. But when you draw the free body diagram and so on, so the answer is quite simple. Okay, quite simple. It's not too tough, too difficult for you. Okay, oh, there's the answer. Okay, there's the answer. So for moment, By 500 Newton. Okay, By is Bx equal to 0. So when you transfer By equal to 500, when you transfer here, okay, you can see that this is downward. Okay, downwards, and Ay, Ax, and so on. So again, you can apply the equilibrium equation, total Fx, Fy, and moment. Okay, you can see that Ax equal to 0, Ay equal to 1166.67. So that is Ay. Okay, and then this is Fa. So Fa. Okay, so this one equal to when F here divided by 2, divided by 2, 1166.67 divided by 2 equal to 583.33. So based on that, you can determine the tau average. Okay, so this one equal to 46.42 Newton per meter square, or equal to 46.42 megapascal. Okay, that is the answer. Okay, any question? This question, this problem is not straightforward, but you have to think. Okay, and then as I mentioned to you, please don't worry. Okay, you can go step by step, free body diagram, force analysis, and then after that you can answer the question. Okay, any question, please? I want to know whether you understand or not. If you feel that you cannot understand, please, please let me know, or maybe you can contact me personally. Okay, you can WhatsApp me and so on. So maybe based on that, I can explain to you. Okay. Okay.
Understand, doctor.
Okay, sir.
Any response? Okay.
Yes, doctor.
Okay, doctor.
So I think this is the example. Again, this example, I think is the same as before. Okay. Okay, the inclined members is subject to the compressive force of 3,000 Newton. Determine the average compressive stress along the smooth area of contact defined of AB and BC. AB and BC, and the average shear stress along the horizontal plane defined as EDB. Okay. So in this case, we have two questions. The first one is to determine the average compressive stress. The average compressive stress means that this is the sigma average compressive stress. So for the stress, we have a normal stress. A normal stress, we have in tension or in compressive. So this is a compressive. And the second question is to determine the average shear stress. Average shear stress is tau. Tau. We have two. So this is the normal force divided by the area. So this one equal to V divided by the area. Okay. So we analyze one by one. So the first part is to determine the average compressive stress. Okay, along the smooth area of contact defined as AB. Yeah? So this is AB and BC. Okay, AB and BC. Okay, so in this case, you have to, if you draw this component, it looks like this. Okay, it looks like this. Okay. Okay, so this is force 3,000. 3,000. Okay, so we have, based on this diagram, we have the normal force to this direction. So this is normal force to this direction for AB, for the AB, and for the BC, this is the normal force. Let's say this is NAB, and then this is NBC. Okay, and the angle is as shown here. So this is 3, this is 4, this is 5. This is 5. This is the angle theta. Okay. So from this diagram, you can determine the NAB. Okay, NAB equal to 3,000. Okay, so 3,000, 3 over 5. 3 over 5. And NBC equal to 3,000, 4 over 5. This is the normal force in AB direction and BY direction. So from here, you can determine the sigma AB and sigma, sorry. So this is BC. So this is BC. This is BC. Sigma BC. Okay, sigma AB equal to this one, and AB divided by the area of AB. Area of AB equal to how much? AB equal to 25 multiplied by 25. That one is multiplied by 40. Okay, 10 minus 6. Okay, this is the area. So this area, or represent this area. Okay, if you can see that here, so this area. Okay, and for the BC, okay, and BC divided by the area of BC equal to 50. Yeah? 50, and this one is 40. Okay, 10 minus 6. So this is the area. So this is the average compressive stress along the smooth area contact defined of AB and BC. Okay. And for the average shear stress along the horizontal defined as EDB, EDB. So the shear along this line, okay, along this line. So the force, shear force here is equal to NBC, equal to NBC. Okay, to this direction, force to this direction equal to NBC, like this. Okay, equal to NAB, equal to NAB. Okay, so this one is N along this line, NAB. Okay, and the area is, this one is 75. Okay, multiplied by 40. Okay, 10 minus 6. So this is the shear stress. Okay, for the plane defined by EDB. Okay, that's all. Okay, so you can check in the solution one by one. Okay, you can check. So this is sigma AB. You can see that here, sigma AB, sigma BC. Okay, this one is referred to the AB. Okay, and this one referred to the BC, BC, this direction. Okay, and then for the tau, average shear stress for the plane. So this one. Okay, N same, and here, as here is same AB. Okay, divide by the area is 75 multiplied by 40. So this is the answer, equal to 0.6 megapascal. Okay, that's all. Okay. Okay, I understand. So that the finish the two very basics in the stress we call as average shear, average normal stress, and average shear stress. The average normal stress represented by sigma. Okay, sigma. Okay, and sigma we have compressive, and then we have in tensile or in tension. In tensile. Okay, in compression or tensile. Compression means that if we have the body like this is the force. Okay, is compressed. But tensile is opposite direction. So you can see that this is the F. So this is in tension or in tensile stress. Tensile stress. And for the tau, we have V over A. So we have a single shear and double shear. Okay, if the single shear, tau equal to V over A. If double, tau equal to half V divided by A. So that is the average shear stress. Okay. So the next part is we call as allowable stress. So this allowable stress is based on what we discussed before this. Okay, what we discussed before this is based on the sigma, and then also based on the tau. Okay, this is we call as allowable stress. Okay, before we proceed, anything you want to ask me? Okay, anything you want to ask me, please? I want to hear from you whether you understand or not. Okay. Hello. Hello. Yeah. You can follow. You can understand.
Yes.
You understand, huh? Yeah, no problem. So far, so good. Okay,
Yes, doctor.
no problem.
Everything is clear.
Okay. So thank you very much for your response. Okay, I think now is 5:15. I think You want to proceed or you want to stop now? Okay, you want to proceed or you want to stop now? Because I think this is very. Sometimes you are very tired, huh? Okay, if you want to
Yes,
proceed, I
doctor.
proceed. You want to proceed or stop?
I think it's better to stop.
Are you with me?
Stop now.
Stop
It was
now,
a tiring day for us, doctor.
Yeah, doctor.
Okay, okay. I understand. I understand. So thank you very much. Okay. So I think it's sometimes quite hard for you to think, to absorb everything. Okay, from the morning